Good morning. So, let us start with the phase change of refrigerant dito sa ating cycle. So, when we're talking about yung cycle natin, and then ang working fluid natin is a refrigerant. At lower temperatures than the boiling point of water, nagkakaroon ng phase change yung ating refrigerant. Ibig sabihin, a good refrigerant has a low boiling point. Yun dapat. So, kung meron tayong simple vapor compression cycle, where we have 4 points kung saan madidetermine natin kung ano yung mga phases na meron dun sa iyong refrigerant. Now, in this figure, we can see the movement of the refrigerant coming from just before entering your compressor, and then entering yung condenser mo, and then going out of the condenser, what happens to your refrigerant, and then after the expansion, tawag dito, expansion valve ata to. Ayun, expansion valve, ano mangyayari sa kanya. And then, going inside your evaporator, ano na ba yung kanyang state. So, we have here the diagram. And as we can see, before entering your compressor and going out of your evaporator, kung saan nangyayari yung, yung cooling and heat absorption ng iyong refrigerant, kung saan yung heat ng iyong load, kukunin ng iyong refrigerant. And then, your refrigerant, before entering your compressor, that is in the state of a saturated vapor. So, kung ikukumpara natin siya sa water or steam, meron tong sariling table. Okay? Tapos na kayo ng termo to, di ba? So, in chart reading, pagpalagay natin, this is water, okay? Or steam or vapor. Kapag saturated vapor, saan mo siya titignan pagdating ng iyong steam table? Siyempre, dun sa saturated tables, where at saturation pressures and temperature, dalawa yung table na yun eh. Tables 1 and 2 when you are looking at your steam tables. Now, going inside your compressor where work will be consumed para i-compress natin yung iyong saturated vapor, what will happen after that? After ng isentropic compression. So, after isentropic compression, your vapor or your refrigerant will become superheated vapor. So, meron yan sariling table. So, di ba sabi ko sa inyo, mag-prepare kayo ng R12, R22, tsaka ammonia. Nakakuha na ba kayo niyan? Kahit PDF copies lang, ha? Hahanapin ko muna yung tables niyan para bibigyan ko kayo ng mas malinaw. So, this is more likely to be kapag superheated ang vapor mo, this is coming from tables eh. Meron tong saturated temperatures and saturated pressures. Now, kapag naman superheated vapor, di ba, tinuturo ko sa inyo noon nung kayo nagte-thermo 2, kailangan natin just 2 points. 2 points on your chart, you can plot the point kung nasaan siya. And then you can see the corresponding value pagdating ng ating superheated vapor. Ano ba yung mga dapat natin tignan dyan? Tignan natin kung meron tayong given enthalpy, meron tayong pressure, temperature, and then we can determine any other parameters na dapat natin i-determine. Such as yung enthalpy niya. Now, going back. After it went to your compressor, what will happen? It will become a superheated vapor. So, if that is superheated vapor, ibig sabihin, napakataas na yung kanyang temperature and pressure. And just before going to your condenser, yung superheated vapor na yon, palalamigin natin yan sa condenser where the heat that it absorbed from your load will be taken out of the system. Either your condenser is water-cooled or air-cooled, kung anong medium yung gagamitin natin for heat exchange. But most commonly, sa isang refrigerator, yung nakikita nyo sa likod, di ba? Yung mga namamawis-mawis. Yung tumutulo po, nasa likod niya, di ba? Makita kayo yan. Ginagawa pa nga yung barbecue grills, di ba? Kapag mga magbubuti. Yung ginagawa ng junk yung refrigerator nyo. Makikita nyo, sila yung parang mga ganito, oh. Ito yan, oh. may cooling fins, tapos mayroong mga ganyan. Diba? Ginagawa pang barbecue grill to. So, that is your cooling fins. Kung saan, air-cooled siya, passively cooled. Kung saan, hangin lang yung dumadaan sa kanya, kinukuha na yung heat dun sa cooling fins. Ganun din sa ating mga aircon. Meron tayong mga condenser dyan, yung mga namamawis. Ibig sabihin, yung heat that is absorbed by your refrigerant is taken out of the system passively by air. Now, in bigger systems, refrigeration systems or cooling systems, we are using cooling towers. Kung saan meron tayong water basin, ginagamit ng condenser natin to cool itself, and then yung water na yon will be evaporative yung cooling, we using a heat exchange between yung tubig and then hangin. And then after going to your condenser, ang ginagawa mo sa condenser kasi, you are returning yung inyong refrigerant in order for it to become a saturated liquid again. Where it will go to your expansion valve. So magkakaroon tayo ng throttling process dyan or constant enthalpy. And after constant enthalpy process, slowly, your refrigerant will become a wet mixture. Kung saan i-condition mo na siya na part of it is wet, part of it is vapor before going back to your evaporator for the cycle of heat absorption. Okay? Ganun lang po yun. So, going to your pH diagram where we can see clearly, ito kasi yung fundamental diagram na dapat nating babasihan when we are talking about refrigeration cycle. Now, parang TS diagram, di ba? But, yung TS diagram pareho rin, nahahati yan sa dalawang regions. Meron kang subcooled region and then superheated region. And then sa pinakataas, that is the critical region. Tinuro ko sa inyo yan nung kayo nag-termo to sa akin. Face-to-face pa yon. But when we are talking about pH diagram, the same lang. The same lang. Where the solid line, the blue lines and then the yellow lines, states different regions. Kapag nandun siya sa subcooled region, kapag saturated yan, under the saturated line, any point that lies beyond that line, that is subcooled. But, when the line or the point lies within the line itself, the state of that point, ibig sabihin that is saturated liquid. If that is in saturated liquid line. Now, going to your right, tignan nyo, yung yellow dito, that is beyond that is a superheated region. Okay? Yung superheated region na yon, nandun nakikita natin yung commonly, the superheated vapor. Okay. Now, when a point lies on that line, ibig sabihin, that is a saturated vapor. Yun yung phase ng iyong fluid. Now, as you can see dito, parang yung diagram natin. At point 1, before going to isentropic compression, your point or your refrigerant is lying on the saturated vapor line, which means yung iyong vapor or refrigerant is simply saturated at state. And after going through compression, papasok siya ng superheated region. It will become a superheated vapor. And just before going to your condenser, punta na condenser mo, dahan-dahan siyang babalik sa saturated vapor. And then, after getting back to your saturated vapor, further cooling is made. So, this is QR. This is QA. Ayan. So, further cooling is made and then ma-attain niya yung kanyang liquid state ulit. Okay? Saturated liquid na siya. And after getting back to throttling process at your expansion valve here, solid line. Ibig sabihin, it will become a wet mixture. It will fall down to the wet mixture region before getting back as a saturated vapor going under the process of evaporator. Okay? Now, that is the part of your pH diagram. Very basic lang yung kanyang pagpapaliwanag. Now, in depth. The left half blue line of the pH curve shows the saturated liquid line, as what I've said. The left part of the diagram represents the subcooled region, so further beyond. The right half is the saturated vapor line, and then further beyond, that is the superheated region. The middle part between the saturation lines represents the combination. So that means it is the wet mixture region. Now, at point 1, the refrigerant exits and carries the heat that is absorbed from the load of the evaporator. Due to its heat content, the refrigerant is ideally to be in the saturated vapor form. Now, after isentropic compression in your compressor, the superheated vapor will enter the condenser. This device is responsible for the superheating and condensation of the refrigerant. Now, as you can see in your pH diagram, from point 2 to point 2 prime, this represents the superheating. The superheating, ibig sabihin slowly bumababa yung temperatura. The superheating process means that it changes the superheated vapor into its saturated vapor form. Okay, slowly. The sensible heat, tinuro ko yan ha, the sensible heat is the heat that is rejected from this process since magkakaroon tayo ng change in phase of the refrigerant. Ayan, there is a change. Yan ang sensible heat. There is a change in, there is a change in temperature, hindi pala phase. Pag may change in temperature ka, sensible heat ang nararamdaman mo doon. That is the heat energy na meron doon. Kapag nagkaroon ka ng change in phase, ibig sabihin doon, that is latent heating. Okay? And then after this superheating, there is a condensation process. From process 2 prime to 3, the refrigerant changes its phase. Ibig sabihin, meron kang change in phase, then that is latent heat. In this process, latent heat is rejected from the refrigerant. Yun yung tinanggal ng iyong condenser. Okay? Now, from point 3, the refrigerant passes through an expansion device or an expansion valve and undergoes throttling, constant enthalpy. Due to pressure reduction, some of the liquid evaporates, but enthalpy remains the same. This can be seen at the pH diagram. So, at point 4, it is a wet mixture now before entering your evaporator. This wet mixture enters the evaporator. Only the saturated liquid part will absorb the heat. Yung liquid part lang, hindi yung vapor form. Until it becomes saturated vapor, and so, the refrigerant will all be saturated vapor at the exit. Sir, bakit hindi tubig ang gamitin natin? Matagal mag-absorb ng heat yung tubig. Unlike itong mga refrigerant natin, di ba sabi ko nga sa inyo, a good refrigerant will have or should have a lower boiling point than that of water. Kasi water is the basis of all the chemicals, of all the substances. Okay? So, that is the phase change in your refrigerant. So, let us go to the entire process. Yung entire process natin, titignan natin kung paano nakukuha yung mga energies dyan. So, let us go with the enthalpy of the refrigerant since we are talking about the energy changes. When we're talking about energy changes in our refrigerant and then our system, enthalpy, yan, ito ang pinagbabasehan natin. The enthalpy of the refrigerant. Now, the enthalpy of the refrigerant depends on its phase form at different temperatures. Okay? Let us base that on the pH diagram. Some enthalpies can be determined using refrigerant tables. Some enthalpies, not all. Okay, not all. So, these enthalpies, ano lang po ba yung ma-determine natin dito? Itong enthalpy nito. Kasi meron tayong saturated tables. Ito, wet mixture. Kasi, yung H3 mo, is equal to HF of the refrigerant at P condenser. Now, yung H3 mo naman kasi is equal to H4. Okay? How about 2? Anong babasihan natin sa H2? Hindi natin alam. Kasi superheated to eh. H1 is Hg at P1. P ng evaporator. Okay? How about 2? So, ang babasihan natin dito is pressure muna. And, syempre, ano pa? May temperature ka ba dyan? Might be. Or pwede rin yung S. Pwede rin temperature. But let us see. Along the way. At the above figure, point 3 and 3,4 has the same enthalpy. Since the process 3 to 4 is throttling or constant enthalpy process. Okay. Now, point 3 is saturated liquid. So, saan po pupunta niyan? Refer to the saturated liquid tables of the refrigerant. Kaya nga pinahanap ko kayo ng tatlong refrigerant. And then, we can see, ito na yun. Sinimplify ko na. H3 will be equal to H4 and then HF at temperature of the condenser. Commonly, temperature lang naman ay binibigay dyan. The temperature of the evaporator and the temperature of the condenser. Now, at point 1, ibibigay sa'yo yung evaporator temperature. The refrigerant, as you can see before going to your compressor, that is saturated vapor. It is also shown in the pH diagram, where point 1 in the saturated vapor line and connected to evaporator temperature or pressure shown dun sa ating figure. Therefore, the enthalpy at point 1 is equal to the enthalpy at saturated vapor or Hg at the temperature of the evaporator. Now, the problem here is the enthalpy at point 2 that can't be determined easily using the refrigerant table since it is a superheated vapor, but you will be given a chart. We can use the pH chart of the specific refrigerant. Either that is R12, R22, and NH3. But along the way, I will tell you something. I will teach you a technique using your calculator. But that can only be used using R12, R22, but not ammonia tables. Kasi iba na yung ammonia niyan. Ammonia tables, ibang-iba kesa dun sa mga R-type refrigerants. Now, in naming the refrigerant, I will tell you that later. So, H2, by chart tayo dyan. So, dito, magkakaiba-iba lang tayo ng chart reading talaga. So, I have here a sample. So, meron yung video below, so you can watch it on your own. But, what better way for us to understand it is to solve a certain problem. So, let us see later. Now, by energy analysis naman sa ating vapor compression cycle. So, we'll go to point 1 and 2. At point 1 and 2, we will determine the power that is consumed by your compressor in order for you to make your saturated refrigerant into superheated refrigerant. Now, for point 1 to 2, paano natin makukuha yung work ng compressor? Siyempre, by energy in, energy out, okay, hindi natin alam yan, di ba? Alamin natin si H2 and H1. And then, energy in, energy out by mass balance and energy balance. The refrigerant is the one that is going into the cycle. So, that is the mass of the refrigerant. Now, lahat ng papasok equal to lahat ng papalabas. So, dalawang pumasok dyan. That is the yung point 1 and then the compressor power. So, we can see that the work of the compressor, the power of the compressor is equal to mref H2 minus H1, where H2 will always be greater than H1. So, check And therefore, the work of the compressor is simply specific to a specific work. This is the power consumption. Where PC is the compressor power, WC is the compressor work, mref is the mass flow rate of refrigerant in kilogram per second or pound per minute or pound per second. H2 is the enthalpy at point 2 that can be determined using your chart. And H1 is the enthalpy at point 1 using tables of the evaporating temperature given dun sa refrigerant. Now, we'll go to your condenser. By looking at the diagram, dalawa yung pumasok, dalawa yung lumabas, isang pumasok. Now, by energy balancing, ganun pa rin naman ang system will arrive with the heat that is rejected by the system, QR. That is mref multiplied to H2 minus H3, where H2 is greater than H3, always. And ang unit nito is in kilowatt. And ER. What is ER? Wait ER is the heat rejected from the refrigerant or the energy rejected. Yan. QR is the heat rejected or ER is energy rejected. Si ER, iba kay QR. Bakit? Si QR kasi is in power. Si ER kasi is in specific energy. Okay? Ganun pa rin naman, mref. H2 is enthalpy at point 2. H3 is enthalpy at point 3 where that is saturated liquid. Now, going to your evaporator. At your evaporator, heat is absorbed. And then, by mass and energy balance, ilan ang pumasok, ilan lumabas. So, dalawang pumasok, isang lumabas. Now, QA will be mref H1 minus H4, where H1 is always greater than H4. Okay, ang unit ito is in kilowatt or in HP. Ang unit naman ng RE, ano ba yung RE? That is the refrigerating effect. This is in kilojoule per second or BTU per pound. Okay? We note that the standard unit of refrigerating capacity in tons of refrigeration is, or simply torr, is, malalaman natin dito mamaya. 1 ton of refrigeration is the rate of cooling required to freeze 1 ton of water at 32 degrees Fahrenheit. Ano ba yung 32 degrees Fahrenheit? That is 0 degrees Celsius into ice at 0 degrees Celsius in 1 day. So, 1 ton of refrigeration. So, 1 ton of water is equal to 2,000 pounds or 917 kilograms. Freezing water at 32 degrees Fahrenheit into ice at 32 degrees Fahrenheit is equivalent to its latent heat of fusion. That is 144 BTU per pound or 335 kilojoule per kilogram. 1 day is equal to 24 hours and 1 hour is equal to 3,600 seconds. In mathematical form, 1 ton of refrigeration is 12,000 BTU per hour or 200 BTU per minute or 211 kilojoule per minute or 3.5167 kilowatts. Ito lang naman po yung kanyang conversion factor. Now, we'll talk about the coefficient of performance. Sabi nila, kapag heat system daw or heat engines, we are talking about efficiency. Ngayon, gaan naman ka-efficient yung ating cycle? And that is the coefficient of performance. The coefficient of performance is the ratio of the refrigerating effect to the work of the compression. Now, let us be accurate. It could also be the ratio of the refrigerating capacity to the power of compression. So that is the heat that is added divided by the power of the compressor, or simply RE divided by ER. That is the COP. The higher the value of the COP means that it has a greater cooling capacity per compressor power. Okay? Mas mataas na cooling capacity and then lower compression power that is used, mas maganda yung iyong COP. Now, at these times, we are talking about thrift-worthy and then frugal machines. Ang ibig ko sabihin, yung nakakatipid tayo sa consumption. And when we are talking about consumption, nakalagay yan dun sa ating mga refrigerator. Di ba yung yellow na papel nakadikit sa refrigerator mo. So, the higher efficiency rating mas matipid daw sa kuryente. So, we are talking about energy efficiency ratio. Ay may kita niyan sa ref niyo yung mga dilaw na pakete. So, also commonly known, expressed as energy efficiency rating or ratio, gives you an insight of how much cooling capacity the unit provides from a specific amount of energy used. Every air conditioner is assigned with specific EER. So, the higher the EER, the better the energy consumption of your cooling unit. EER stands for energy efficiency ratio. And it is calculated by dividing the BTU or the British Thermal Units rating by the wattage power. Example, 12,000 BTU air conditioner that uses 1,200 watts has an EER rating of 10. So, the higher the EER, the better. So, paano po ba natin makukuha yung EER? Simply, EER is equal to 3.41. At okay na yan, COP. That is EER. Okay? For further discussion, mas maganda, i-discuss natin yung sample problem. So, I have here a sample problem that uses ammonia. So, i-prepare nyo yung ammonia tables and after 5 minutes, we'll go to the discussion. Okay? I think that will be all for the phase change and then the enthalpy and energy around your cycle. Okay? Tandaan nyo yung notable conversion factors and how it came by. So, let us see kung ma-solve natin yung problem. Okay? This is the problem. So, let's continue after 5 minutes.